100 days. It's a benchmark we often hear about in politics. But we're taking that time frame and aiming it, well, straight at the cosmos. Because in just the first 100 days of the Trump-Vance administration, NASA's been, wow, a whirlwind of activity, really pushing boundaries at what feels like warp speed.
That's absolutely right. Yeah, we've been digging into all the reports and data that's really our source material for today, and it's clear these first few months, incredibly dynamic.
Right.
It's much more than just, launches and landings. It's about strategically building towards a sustained and vibrant future beyond Earth. Our goal here in this deep dive is really to unpack the significance of these developments. What do they tell us about NASA's trajectory right now?
Okay, let's unpack it then. Right out of the gate, we saw astronauts coming home. And then, boom, new crews heading straight up to the ISS. It feels like this continuous loop of human presence up there.
Precisely. The safe return of Crew 9 back in March. That was NASA's Nick Hague, Suni Williams, Butch Wilmore, and Alexander Gorbanov from Roscosmos. That really highlighted the ongoing international teamwork, which is just so vital for the station.
Yeah.
And what's really notable is how quickly Crew 10 followed. That ensures American-led science and, diplomacy just continue nonstop in orbit.
And then there's Don Pettit, coming back on his 70th birthday after 7 months. That's incredible. Says a lot about human drive.
It really does. His return, it's not just about dedication, but also the potential for people to contribute way up there, even at an advanced age. And almost right after he landed, we saw Jonny Kim launch. His first mission, 8 months, focused on some really interesting research, this constant rotation. It's the lifeblood of the science on the ISS.
And we also found out who's on Crew 11, right? Launching next summer sometime.
Yeah.
Another mix of veterans and new faces, different countries.
Yeah, exactly. Zena Cardman and Mike Finke from NASA, Kimya Yui from JXA, Oleg Platonov from Roscosmos. It just underscores, again, those crucial international partnerships you need for these really long, complex missions.
Yeah.
And the fact that NASA is already assigning crews that far out, it shows a clear, sustained, long-term plan for human spaceflight.
Plus, Chris Williams getting ready for his first flight later this year. It really does feel like a constant stream of talent ready to go to space.
That's a key point. NASA isn't just looking at right now. They're actively cultivating that next generation of explorers. This continuous pipeline of skilled American astronauts is, fundamental to keeping the U.S. leadership in space going.
Okay, now here's where it gets, I think, really interesting. NASA's inviting private companies to propose sending their own astronauts to the ISS. That feels like a pretty big shift.
It is a significant evolution, yeah. This move, inviting U.S. industry for private astronaut missions, it's a decisive step towards a more self-reliant American presence in low Earth orbit. It's about nurturing a stronger national space economy, unlocking new ways for commercial research, maybe manufacturing, things that might not fit the traditional government model.
And all this ISS activity, it needs supplies, obviously.
Yeah.
SpaceX just did its 30-second cargo run. What kind of stuff are they sending up?
That's right. CRS-32 delivered a hefty 6,700 pounds of cargo. It supports a whole range of cutting-edge science. What stands out are maybe a few things. New ways to control those free-flying robots inside the station.
Oh, cool.
An advanced air quality monitoring system, which is obviously vital for crew health on long trips, and 2 incredibly precise atomic clocks.
Atomic clocks in space. What's the point of that?
Well, these aren't your standard clocks. They're designed to test Einstein's theory of relativity in space, basically, and enable super precise timekeeping.
Okay.
Now, it sounds abstract, but accurate timekeeping in space. It has huge implications for better navigation systems, think GPS, but way beyond Earth. Crucial for future interplanetary travel, coordinating spacecraft, that kind of thing.
Got it. Okay, so the ISS is humming, but let's look further out. I saw some interesting stuff on propulsion tech and landing capabilities.
Right. This is where we see the building blocks for the moon and eventually Mars. That successful hot fire test of the first 12-kilowatt solar electric propulsion thruster, the SEP thruster, that's a really big milestone.
SEP, solar electric.
Exactly. It uses sunlight for power, makes the thrusters incredibly efficient. The fuel savings compared to traditional chemical rockets, huge. It makes those long-duration, deep space missions, especially to Mars, much more practical, more affordable, too.
So it's like getting better mileage, essentially, for space.
That's a good way to put it. These FE thrusters are key for hauling heavy cargo to the moon, eventually Mars orbit for maneuvering once you get there, and just the long transit between planets.
And speaking of getting to Mars, entry, descent, and landing, EDL. That always sounds like the really scary part. Lots of tests mentioned there.
It is incredibly complex, high risk. So NASA completing 4 EDL tech tests in just 3 months. That shows they're really accelerating development, landing big things safely and precisely on Mars. With that thin atmosphere and tricky terrain, you need advanced tech. These tests are pushing those limits.
And that deep space optical communications experiment? Laser beams across space. That sounds very sci-fi.
It's rapidly becoming sci-fact. This experiment, it's on the Psyche mission, which is heading to that metal asteroid, by the way.
Right, Psyche.
It successfully demonstrated high-bandwidth communication using lasers, not radio waves. For future Mars crews, think about it sending large amounts of data back and forth quickly. Absolutely essential. For mission control, astronaut comms, everything.
Okay, now back towards the moon for a minute. Lots happening with commercial lunar landers, it seems.
There is indeed. Firefly Aerospace's Blue Ghost Mission 1 that successfully delivered 10 NASA payloads to the surface.
10 payloads.
Yeah. And it wasn't just about getting there. It was about testing and refining key tech and procedures that are directly relevant for Mars, too, like autonomous landing, collecting data in that tough lunar environment.
And intuitive machines also landed, right?
Yeah.
And wasn't the furthest south anyone's landed on the moon?
That's correct. Their IM-2 mission hit that milestone, landing closer to the lunar South Pole than ever before. And crucially, it gathered vital data from that really challenging but scientifically fascinating region.
Why is that data so important?
Well, that kind of info is invaluable for figuring out how to operate spacecraft, maybe extract resources in different lunar terrains, and that knowledge. Directly transferable to exploring Mars, especially its poles where we think there's significant water ice.
I also read something about cameras catching the engine plume hitting the surface during landing. That sounds useful.
Absolutely. NASA cameras on Blue Ghost got unprecedented footage of how the engine exhaust plume interacts with the lunar dust, the regolith. That visual data, the scientific data, it's incredibly valuable for engineers designing safer, more reliable landing systems, not just for the moon, but Mars too, where dust is a huge challenge. We're getting a really detailed picture of the physics involved right at landing.
And those Gale-PS cameras, they took thousands of pictures during descent.
Over 9,000 images. The stereo cameras for Lunar Plume Surface Studies SCAL-PSS, they give this wealth of 3D information about how landers affect the terrain.
3D, okay.
Yeah, so that data directly feeds into designing future spacecraft, refining procedures. And it's not just on Firefly's lander. New SCAL-PSS hardware is going on Blue Origin's Blue Mark 1 mission too. So the value's clearly recognized.
It really sounds like they're meticulously building up this understanding of lunar landings, piece by piece.
Precisely. And another interesting bit on Blue Ghost, the LUGRA experiment, that's the Lunar Global Navigation Satellite System receiver. It actually picked up GPS signals from Earth while it was sitting on the moon.
Really? GPS from the moon?
Yeah. It might not sound revolutionary at first, but it's a big step towards developing autonomous positioning systems for future moon and Mars operations. Could mean less reliance on constant tracking from Earth.
What about that pesky lunar dust? I always just hear that's a massive problem.
It is a huge operational challenge. It's super fine, abrasive, sticks to everything. So the successful demo of the electrodynamic dust shield, that's a vital achievement.
Electrodynamic dust shield. How does that work?
Basically, it uses electric fields to actively clear the dust off sensitive equipment. Think rovers, habitats, solar panels. Crucial for keeping things working long-term on the moon and Mars, like a self-cleaning system for space hardware.
So it really does seem like all these lunar missions, all this tech development, it's all feeding directly into the Mars ambitions.
Absolutely. The moon is serving as this invaluable proving ground. It's closer, more accessible, lets us test the tech, the operations, even the human factors needed for the much tougher job of sending people to Mars.
Right.
Even the research astronauts are doing right now on the ISS about crew health on long missions. That's directly relevant for managing the risks of a long trip to Mars. And that NASA Moon to Mars architecture workshop they held, that really shows the coordinated strategic effort to refine the big picture plans.
Okay, let's shift to the big one, the Artemis program. NASA's push to get astronauts back to the moon. What progress did we see in these first 100 days?
We saw some really significant milestones for Artemis II, specifically in this window. Completing the stacking of those twin solid rocket boosters, that's a massive step. This mission, sending astronauts around the moon for the first time in, over 50 years? It's becoming tangible now.
And a whole rocket is coming together down at Kennedy Space Center piece by piece.
Exactly. The huge core stage of the Space Launch System, the SLS rocket that's been joined with the boosters, the launch vehicle stage adapter that connects the core stage to the upper stages that's been lifted into place, and the interim cryogenic propulsion stage, the upper stage that gives Orion the final kick towards the moon, that's been received too. Even just moving that giant SLS core stage is a complex job, another key integration step. Every piece coming together marks real progress towards launch.
What about the Orion spacecraft itself? The capsule for the astronauts?
Critical work there, too. The solar array wings have been attached, absolutely vital for powering Orion on its journey.
Right, power.
And the protective fairings are installed on the service module. Those shields protect it during launch, during ascent, as it goes farther than any human-rated spacecraft has in decades.
And they're even working on the next mobile launcher already. It sounds like they're planning way beyond just Artemis II.
They absolutely are. Continuing work on the new mobile launcher, installing its 6th module recently. That shows a long-term commitment to the infrastructure you need for a whole series of Artemis missions, to the moon and maybe beyond.
And it's not just the hardware, right? They're practicing getting the crew back safely, too.
That's right. That Artemis II recovery training with the Department of Defense, using the USS Somerset, crucial preparation, ensures the teams, the procedures are all ready to go to safely retrieve the astronauts after their historic flight. Every phase, launch to splashdown, is being rigorously planned and practiced.
They even unveiled the mission patch. Those patches always have some cool symbolism.
They do indeed. The AII on the Artemis II patch, it signifies the second major Artemis flight, obviously, but it also stands for an endeavor of discovery for all and by all. Really captures that inclusive, ambitious spirit.
Okay, let's switch gears a bit. America First in Space initiatives. This seems like a pretty broad category, beyond just Moon and Mars.
It is. And one of the most significant, really exciting developments here is the first big science results from SPHEREx, the analysis of that sample from asteroid Bennu.
Oh yeah, Bennu. What did they find?
Get this. Salty brines, essential amino acids, and all 5 DNA nucleobases. The fundamental building blocks of life.
Wow. Seriously?
Seriously. It's a monumental finding. Strongly suggests these ingredients might have been common in the early solar system. And this is from just a tiny bit of the sample. It really cements U.S. leadership in planetary science. And the potential in the rest of that sample is just incredible.
That's absolutely astounding. And it's not all deep space, right? NASA got recognized by Time magazine.
Exactly. Being named one of Time's best companies for future leaders, that highlights NASA's role in fostering the next generation of American innovators, scientists, engineers, vital for keeping that edge.
There were also contracts awarded for Earth science missions. That's important for, well, understanding our own planet.
Absolutely. These contracts to U.S. companies, they do double duty. They advance our understanding of critical Earth systems, climate, weather, environmental changes. But they also strengthen the American industrial base, create high-tech jobs right here.
I saw something about NASA helping Boeing test autonomous taxiing for airplanes. That seems a bit different for NASA.
It might seem so, but it really shows the breadth of American leadership in aviation tech, too. NASA working with Boeing on digital and autonomous taxiing using simulations. It's about making our airspace safer, more efficient, integrating these new autonomous capabilities.
And NASA's own Starlink spacecraft, we're talking to SpaceX's Starlink satellites, coordinating movements autonomously.
Yeah, that's a critical development for managing the increasingly crowded space around Earth, successfully demonstrating automated space traffic coordination between NASA's Starlink formation flyers and SpaceX's huge Starlink constellation. That shows proactive steps to reduce collision risks. Really important for long-term space safety.
There was even a university competition about aviation for the agriculture industry. That's specific.
It is, and it shows how NASA's Gateways to Blue Skies initiative tries to apply American aviation ingenuity to practical problems, enhancing efficiency, sustainability, and farming using aerospace tech. It's a great example of bringing space innovation down to Earth.
And United Airlines pilots testing NASA tech to cut flight delays. I bet a lot of listeners would appreciate that one.
Absolutely. Successful tests by United pilots using NASA tools to better navigate bad weather, minimize delays. That's a clear case of NASA R&D having a direct positive impact on everyday travel.
Now, SPHEREx, that new astrophysics observatory that launched recently, what's its mission?
SPHEREx, yeah, launched on a Falcon 9. It's tackling some really fundamental questions about the universe. Doing an all-sky survey in infrared light, looking at how galaxies formed, searching for life's building blocks in interstellar clouds, even probing the very early universe, the inflationary epoch.
And it's working okay so far.
Early signs are very positive, yeah. The detectors are performing as expected. Promising start.
And it wasn't the only launch, was it? Some smaller satellites, too.
Correct. 4 small sats for NASA's Punch mission went up with SPHEREx. They're studying the sun's outer atmosphere, the corona, and where the solar wind comes from.
Okay.
And separately, NASA's EASY mission launched 2. That's a trio of small sats studying auroral electrojets in our atmosphere. Those play a big role in space weather. And EASY-E's already started taking its first measurements.
What about the X-59? The quiet supersonic plane. Any news there?
Yes, another key milestone cleared. Successful engine speed hold test. Confirms the engine control system works at critical speeds, brings it closer to that first flight, and potentially, quiet supersonic travel over land again someday.
And NASA Tech is even helping fight wildfires.
Absolutely. They developed a prototype, the Portable Airspace Management System, PAMS. It helps coordinate all the air traffic drones, helicopters, planes during wildfire responses, even when visibility is bad. Could significantly boost safety and effectiveness.
The Parker Solar Probe just keeps going, breaking records, getting closer to the sun. That mission is amazing.
It truly is. Its 23rd close approach set new records for closeness and speed, invaluable data about our star, and its contributions were just recognized with the prestigious Collier Trophy. Well deserved.
Good to see NASA helping out with disaster response here on Earth, too.
Yes, the NASA Disasters Response Coordination System was activated to support communities hit by severe weather in over 10 states during this period. They provide satellite imagery, data analysis, expertise to help with preparedness, response, and recovery.
And those air taxi tests. Another peek into future city transport.
Exactly. That flight test campaign, using a Joby Aviation demonstrator, it's all about safely integrating these eVTOLs, electric vertical takeoff and landing aircraft, into the national airspace, standardizing tests, improving collision avoidance, paving the way for urban air mobility.
NASA even put out a documentary about planetary defense. Sounds important.
It is indeed. Planetary Defenders highlights the crucial work of NASA's Planetary Defense Coordination Office detecting, tracking, potentially deflecting asteroids. Apparently, it got strong initial viewership, too, so people are interested.
And the Artemis Accords keep growing. More nations signing on. That feels important for working together in space.
Very significant. Finland and Bangladesh joined, making it 53 and 54 nations. It reaffirms this growing global consensus on peaceful, sustainable, responsible space exploration under U.S. leadership, strengthens the framework for the moon and beyond.
There was also some work with an F-15 jet supporting the X-59.
Yeah, calibration flights. They put a new shock-sensing probe on a NASA F-15D research jet. The data they get helps verify the X-59's quiet, supersonic performance when it flies. Real team effort there.
And the Lucy spacecraft had another asteroid flyby on its way to the Trojans.
That's right. Lucy flew past asteroid Donald Johanson, got valuable science data, images of this ancient solar system remnant, shows the spacecraft is performing great as it heads towards its main targets.
Can't forget Hubble. Still going strong after 35 years.
Absolutely. Hubble's 35th anniversary was marked with stunning new observations, a testament to its incredible legacy and the vital science it still produces.
The SPHEREx team even rang the closing bell at the New York Stock Exchange. That's cool outreach.
It's a fantastic way to connect NASA's cutting-edge science with a broader audience, yeah. And NASA also picked up multiple Webby and People's Voice Awards for their digital engagement. Shows they're doing a good job communicating all this complex stuff.
What about electric propulsion for big airplanes? Any movement there?
Big step, actually. Successful testing of a 2.5 megawatt electric motor from Wright Electric, part of NASA's Electric Aircraft Testbed project. Moves us closer to electric propulsion for large commercial aircraft. Quieter, greener, maybe cheaper flights someday.
And finally, NASA's sharing some of its software tools with U.S. companies.
Yes, the GlenIce tool. NASA developed it for handling aircraft icing challenges. Now U.S. entities can request it through the NASA software catalog, helps them build safer, more efficient aircraft using NASA's expertise.
Wow, okay. That is an astounding amount of activity to cover in just the first 100 days. It really does feel like NASA is operating at, well, rocket speed under the new administration.
It certainly does. And when you pull all these different achievements together, you see some clear themes, right? Significant, sustained progress in human spaceflight. A clear, ambitious strategy for the moon and then Mars. Strong international partnerships holding up. This relentless push for tech innovation across so many areas. And always that underlying commitment to American leadership in space and aerospace.
So thinking about this incredible momentum in really a pretty short time, it makes you wonder, what could the next 100 days hold? Or the next few years? What does this mean for our understanding of the universe, our place in it? What specific thing we talked about today are you, our listener, most excited to keep an eye on?
That's the really captivating question, isn't it? With this kind of foundation being laid, the pace could genuinely accelerate. I really encourage you, if any of this sparked your interest, to dig deeper into the specific missions or technologies we touched on. NASA's website is a fantastic resource for that.
Absolutely. It is undeniably an exhilarating time to be looking up. Thanks for taking this deep dive with us today.